A body starting from rest moves with uniform acceleration. It covers a distance of x1 during the third second and distance x2 during the fifth second of its motion. Then the ratio of x2 by x1 is, four options are 5 by 3, 5 by 9, 9 by 5 and 25 by 9. So in order to solve this, let's use the kinematic equation. S is equal to u plus a by 2 2n minus 1. So let x1 be the first distance traveled. So that is, since the body is starting from rest, so the initial speed would be 0. Uniform acceleration 2 into the third second minus 1, which is equals to 5a by 2. For the second displacement, again, but here the n, that is the time period, would be 5 minus 1, so it becomes 9a by 2. So the ratio of x2 by x1 is nothing but 9 by 5. So that is our answer C. A person travels 4 meters to the north, then he turns right and covers a distance of 6 meters. Then he turns to the left and covers a distance of 4 meters. How many meters is he away from the starting point? 16 meters, 14 meters, 12 meters and 10 meters. Let us draw the vector diagram of his movement. Initially he moves towards the north for 4 meters. Later he turns right and moves a distance of 6 meters. Again he turns left and moves 4 meters. So at this position, this is the displacement of the body. And this, as you can see, since 4 meters and 4 meters, since the sides are equal, this segment bisects this segment. Hence, the 6 meters is divided as 3 meters and 3 meters. So let's look at this triangle. In this triangle, the length of this side is nothing but root of 4 square plus 3 square, which is 5 meters. Similarly, in this triangle, using Pythagoras, the length of this side is root of 4 square plus 3 square, which is again 5. So the addition is 5 plus 5, that is 10 meters. Hence, answer is option D. The velocity of a body depends on time according to the equation v equals 20 plus 0.1 t square. The body is undergoing, the four options are uniform retardation, uniform acceleration, non-uniform acceleration and zero acceleration. Let's look at the equation v equals 20 plus 0.1 t square. So the formula for acceleration is nothing but differentiation of v with respect to time, which can be given as 0.2 t, since the differentiation of 20, which is a constant, is 0, and differentiation of 0.1 t square can be written as 0.2 t. Now as we see that acceleration is time dependent according to this relation, and hence since the acceleration is not constant, so the body is moving with a non-uniform acceleration, and hence option C is the correct answer. A car moving along a straight highway with a speed of 108 km per hour is brought to rest within a distance of 100 meters. How long does it take for the car to stop? The four options given are 14 by 3 seconds, 20 by 3 seconds, 25 by 3 seconds and 32 by 3 seconds. Let us use the kinematic equation v square is equals to u square plus 2as. Since over here the unknown parameter is acceleration, let's find out acceleration. But before that, since the speed given is in kilometers per hour, let us convert that into meters per second as 108 into 5 by 18, which turns out to be 30 meters per second. This is the initial speed. Substituting the value of u, we get v is equal to 0 since the car has come to a rest. So v is substituted as 0. U square is 30 square plus 2 times acceleration into the displacement. So therefore, acceleration is equals to minus 900 upon 2 into 100. The value of s over here is substituted as 100. Yeah. So acceleration, we get it as minus 9 by 2 meters per second square. The minus sign shows that the body is coming to a rest, that is, it is in the form of a retardation. Therefore, the time period that is taken is v minus u upon a, which is nothing but 0 minus 30 upon minus of 9 by 2. So that can be written as 20 by 3 seconds. Hence, option B is the correct answer. A car moving with a speed of 40 kilometers per hour can be stopped by applying brakes after at least 2 meters. If the same car is moving with a speed of 80 kilometers per hour, what is the minimum stopping distance? The options are 8 meters, 2 meters, 4 meters and 6 meters. In order to solve this, let us look at the kinematic equation v square equals u square plus 2as. Let us try to find out a relation between the initial speed and the stopping distance, since acceleration would be uniform and since the car is coming to a rest, the final velocity would be 0. Therefore 0 equals u square plus 2 times a into s1. However, since the car is coming to a rest, the acceleration would be negative and hence there would be a minus sign over here. So this is for the first case. Similarly, for the second case, 0 would be equal to u square minus 2as2. So let u1 equals 2as1, u2 would be equal to u2 square would be equal to 2as2. So the ratio of s2 by s1 is given as u2 square by u1 square, and solving that, u2 is 80 square by 40 square. So the answer is 4. Hence option C is the correct answer. A bullet moving with a speed of 100 meters per second can just penetrate two thin plates of equal thickness. What is the number of such plates penetrated by the same bullet when its speed is doubled? The four options are 6 meter, 6 plates, 10 plates, 4 plates or 8 plates. Let us consider S1 to be the distance after which it stops, and since in the first case it's given as two thin plates, so let S1 be the value of two thin plates. Let S1 be the distance or the thickness of two thin plates. Now using the relation v square is equals to u square plus 2as, the velocity, final velocity is 0 for the first case u1 square and 2as1. But since the bullet is coming to a stop, there would be a retardation and hence a negative sign. Therefore, S1 would be u1 square upon 2a. Similarly, for the second case, v2 square is equal to u2 square minus 2a s2. Therefore, s2 can be written as u2 square upon 2a again. So S2 by S1 is given as u2 square by u1 square. Now since the speed u2 is twice u1, therefore u2 square is equal to 4 times u1 square, which means u2 square upon u1 square is equals to 4. So S2 upon S1 is equals to 4. So S2 is equals to 4 times S1. S1 is the number of plates, which is 2. So S2 will be 4 into 2, that is 8. Hence option D is the correct answer. A man is moving on a straight road towards north with a uniform speed of 5 km per hour. The speed of the man remains unchanged when he turns through 90 degree and moves towards the west. What is the change in the velocity of the man in the turning process? The four options are 0, 5 root 2 kilometers along southwest, 5 root 2 kilometers along northwest, and 5 kilometers per hour along the west. Let us draw the vector diagram. Since the man moves towards the north initially and then moves towards the west, so V1 bar and V2 bar. V1 bar is equals to 5 kilometers per hour and V2 bar is equals to 5 kilometers per hour itself. So let's just make a vector triangle V2 bar. So the V1 bar in the north direction can be written as minus of V1 bar in the south direction. So the man moving through the north turns through 90 degree and moves towards the west. Since V1 is equal to 5 kilometers towards the north, it can be written as minus V1 bar, which is equals to 5 kilometers but in the south direction. Therefore, change in velocity is given by V2 bar minus V1 bar. So which can be written as delta V as modulus of V2 bar plus negative of V1 bar. So delta V can be written as root of V2 square plus V1 square, root of 5 square plus 5 square, which is equals to root 50, that is 5 root 2. Therefore, change in velocity is 5 root 2 kilometers along the line AC, which is nothing but along southwest. Hence, option B is the correct answer. An aeroplane is flying horizontally at a height of 3,464 meters above the ground. The angle subtended by the aeroplane at a ground observation station when it moves from T1 is equals to 10 seconds, T2 is equals to 20 seconds is 30 degree. What is the speed of the aeroplane? The options are 150 meters, 175 meters per second, 200 meters per second and 250 meters per second. Let us assume that the plane is moving horizontally and after a point that is 10 seconds it reaches a point A and it travels further and after 10 more seconds, that is after 20 seconds, it reaches point B. So the angle subtended by the point B is 30 degree and this is at a height of 3,464 meters. So basically we need to find out the velocity between the points A and B. In order to do that, let's find the distance of AB. So in this triangle AOB, tan 30 is equals to AB upon 3,464. So AB is equals to 3,464 into 1 by root 3, which is equals to 2,000 meters. So the speed of the plane V is given by distance upon time, that is 20 seconds minus 10 seconds, which is 10 seconds, and hence that is 200 meters per second. Hence option C is the correct answer. A body of mass 0.4 kg starting at the origin at t is equals to 0 with a speed of 10 meter per second along the positive x-axis is subjected to a constant force F is equals to 8 newtons towards the negative x-axis. What is the position of the particle after 25 seconds? The options are minus 6,000 meters, minus 8,000 meters, 4,000 meters and 7,000 meters. So let's just assume that this is the center of the line at x equals 0. The body starts in the positive x direction, but whereas the force is acting along the negative x direction. So since it is acting against the body, there is retardation. And retardation A is given by F by m, which is 8 newtons force over a mass of 0.4 kgs, that is 20 meters per second square. This 20 meters per second square is nothing but retardation. So it will be negative later on. So after t is equals to 25 seconds, we can use the formula S equals ut plus half at square. Note that the value of acceleration here would be minus 20 since there is retardation. So 10 times 25 minus half of 20 meters per second square into 25 seconds square. So x would be 250 minus 6250, which is minus 6000 meters. Hence option A is the correct answer. If a body loses half its velocity on penetrating 3 centimeters in a wooden block, then how much will it penetrate more before coming to rest? The four options given are 4 centimeters, 3 centimeters, 2 centimeters and 1 centimeter. Let us look at this problem into two halves. Assume that this is a bullet which penetrates to a depth of 3 centimeters. So let this part be the first half of the problem, and the second half of the problem we consider this as another part, the unknown distance that it penetrates in the remaining time. So initial speed u1 is some value, whereas the final speed at this point would be u1 by 2, since it loses half its velocity. So the final value v for the first case would be u1 by 2. Using the relation v square is equal to u square plus 2as and substituting v as u by 2. So u by 2 square is equals to u square plus 2a into s is 3 centimeters. Now the acceleration over here, since the body is coming to a rest, would be retardation, and hence there would be a negative sign. Therefore, finding the value of a, we get a as minus u square upon 8. Now the same bullet has the same acceleration, or I could say the same retardation, and it continues. Let us consider second motion for the second case. So in that, the initial velocity becomes u1 by 2, whereas the final velocity becomes 0, and using the same relation v square minus u square is equals to 2as. So 0 equals u by 4, u square by 4 is equals to 2 times the value of retardation, which is minus u square by 8 into s. Therefore the value of s is equals to 1 centimeter. Hence option D is the correct answer. The velocity of a particle is given by v equals root of 180 minus 16x meters per second. What is its acceleration? 8 meters per second square, 16 meters per second square, minus 8 meters per second square and minus 16 meters per second square. The velocity is given as under root of 180 minus 16x. Let us simplify this. V square equals 180 minus 16x. So we need to differentiate both sides with respect to t. So 2v dv by dt is equals to minus 16 dx by dt. Dx by dt is nothing but velocity. Therefore 2v dv by dt is equals to minus 16v. Hence the v gets cancelled. Dv by dt is nothing but acceleration, which is equals to minus 16 upon 2, which is minus 8 meters per second square, and hence option C is the correct answer. A particle moving along a straight line has a velocity v meters per second when it cleared a distance y meter. These two are connected by the relation v is equals to root of 49 plus y. When its velocity is 1 meters per second, its acceleration in meters per second square is, the four options are 1, 2, 7 and 0.5. The velocity is given by the relation v equals root of 49 plus y. So dv by dy can be written as half of 49 plus y raised to minus half, and acceleration, which is given by dv by dt, can be simplified as dv by dy into dy by dt, which is dv by dy into v, since dy by dt is nothing but the velocity. Hence acceleration is v times dv by dy, which is nothing but 49 plus y raised to half into half of 49 plus y raised to minus half. So this plus half and minus half gets cancelled. So the value of acceleration is half, which is 0.5 meters per second square. Hence option D is the correct answer. A particle moves along a straight line OX. At the time t in seconds, the distance x in meters of the particle from O is given by x is equals to 40 plus 12t minus t cube. How long would the particle travel before coming to rest? The four options are 10 meters, 24 meters, 56 meters and 40 meters. So the value of displacement x is given by 40 plus 12t minus t cube. Now when the particle comes to rest, the velocity becomes 0 and velocity is given by dx by dt. So let us simplify this relation with respect to, let us differentiate this relation with respect to t. So what we get as v is equals to dx by dt, which is 12 minus 3t square. When v is equals to 0, let us equate this to 0. Therefore 3t square is equals to 12, t is equals to 4, t square equals 4. So t would be 2 seconds, which means the particle comes to rest after time t equals 2 seconds. Let us put the value of 2, t is equals to 2 in the equation. So 40 plus 12 times 2 minus 2 cube, which is given as 40 plus 24 minus 8, which is equals to 56 meters. Hence option C is the correct answer. A truck starts from rest and moves with an acceleration of 1.5 meters per second square. At the same instant, a Maruti car 150 meters behind the truck starts from rest with an acceleration of 2 meters per second square. What is the time after which the car will overtake the truck? The four options given are 5 root 6 seconds, 10 seconds, 10 root 6 seconds and 8 root 6 seconds. So let x be the distance travelled by the truck and let t be the time. Let t be the time before which the car overtakes the truck. So the distance travelled by the truck for the time t would be given by the relation s is equals to ut plus half at square. In this, substituting the value of s as x and u, the value of u as 1.5. Oh, the value of u would be 0, since that's, make a note that the value of u would be 0 since the truck starts from rest. So half, acceleration is 1.5 and time is unknown. Let's write this as equation 1. Now for the same car, the distance traveled would be x plus 150, since it has to cover an extra distance of 150 meters from the behind. So x plus 150 is equals to half 2t square, using the same relation. So let's write this as the second equation. So dividing 2 by 1, we get x plus 150 upon x is equals to t square upon 2 upon 1.5. T square gets cancelled on both sides. Therefore, the value of x turns out to be 450 meters. Now this is the distance traveled by the truck. So for the car, t square, let's substitute this value in equation 1. Therefore t square would be 2x upon 1.5. Therefore, which is 2 into 450 upon 1.5. Therefore, t will get a value of root of 600, which is nothing but 10 root 6. Hence, option C is the correct answer. A motorist traveling at 20 meters per second sees a child on the road when he is 150 meters away from the child. He immediately applies the brakes and the car decelerates uniformly at the rate of 2 meters per second square. His reaction time is 0.5 seconds. What is the distance between the car and the child when the car comes to rest? The four options are 20 meters, 30 meters, 40 meters and 50 meters. Let's draw the sum. Initially the motorist as point A, and let B be the point after 0.5 seconds, which is his reaction time. So distance between AB is given, since the car is at a uniform speed, so distance traveled in 0.5 seconds is given by 0.5 times 20, which is nothing but 10 meters. So distance AB is 10 meters. At point B, the motorist applies the brake, and let's say he stops at a point C, and let the child be at a point D. So B to C, the velocity at B is 20 meters per second, whereas at point C is 0 meters per second, and the deceleration is given as 2 meters per second square. So let us use the formula Vc is to Vb minus 2As. So Vc is 0, Vb is 20 square minus 2 times the acceleration is given as 2 and displacement s. Therefore s is equals to 100 meters. So this s, which is nothing but Bc, is 100 meters. So since the child is 150 meters away and he stops at, therefore the total distance traveled AC is 10 plus 100, which is equal to 110. And if you see, the value of CD would be 150 minus 110, which is 40 meters, and hence option C is the correct answer. The acceleration A in meters per second square of a particle is given by A is equal to 3t square plus 2t plus t plus 2, where t is the time. If the particle starts with velocity u is equals to 2 meters per second at t is equals to 0, then the velocity at the end of 2 seconds is, the four options given are 36 meters per second, 18 meters per second, 27 meters per second and 12 meters per second. So the acceleration, which is given as dv by dt, is 3t square plus 2t plus 2. So dv can be written as 3t square plus 2t plus 2 times dt. So integrating this, we get v equals 3t cube by 3 plus 2t square by 2 plus 2t, t cube plus t square plus 2 times t. If the value of u would have been 0, then the velocity after 2 seconds would be given by 2 cube plus 2 square plus 2 into 2, which is nothing but 16 Now, but since u is equals to 2, so additional 2 meters per second is added. So hence velocity would actually be 16 plus 2, which is 18 meters per second. Hence option B is the correct answer. Two bodies start with velocities 4 meters per second and 2 meters per second and travel along straight lines along parallel tracks. The accelerations are 1 meters per second square and 2 meters per second square. If they reach the final destination in the same time, then the length of this path traveled by them is, the options are 12 meters, 16 meters, 20 meters and 24 meters. Now for both the bodies, the path traveled S1 is equals to S2 and the time taken T1 also equals T2. So both bodies start and reach at the same point, but the variation here is that the first body has 4 meters per second as the initial speed, and whereas the second body has 2 meters per second, and the acceleration here is 1 meters per second square, whereas acceleration in the second body is 2 meters per second square. So that's the difference. So therefore the equation S equals ut plus half at square can be equated to both of them. So u1 t1 plus half of a1 t1 square is equals to u2 t2 plus half a2 t2 square. Since the time taken is the same, since the time taken for both the bodies is same, we can divide the entire equation by t1 by t. Actually, since the time is same, let us just write t, and dividing both sides by t, we get u1 plus half at a1t is equals to u2 plus half a2 times t. Now let's substitute the values. We get 4 plus t by 2 is equals to 2 plus t. So solving for t, we get t value as 4 seconds. Now s is equals to 4. Let us substitute for the value of t in one of the equations. So we get half, which is equals to 16 plus 8, which is nothing but 24 meters. Therefore the answer is option D. A boy throws a ball vertically upwards from a river bridge with a velocity of 5 meters per second. It strikes the water after 2 seconds. What is the height of the bridge? Take g is equals to 10 meters per second square. The four options given are 7 meters, 8 meters, 9 meters and 10 meters. So let us look. Since the boy is standing on the bridge and the ball is thrown first vertically upwards, it reaches a point where the velocity becomes 0, and after that it starts falling towards the lake and it touches the water surface after t is equals to 2 seconds total. So the initial velocity at this point becomes 0 and it has an acceleration of 10 meters per second square. So first let's look at the height which is traveled so that the velocity becomes 0. So v is equals to u plus at. Since the final velocity is 0, v is equals to u minus gt. The minus sign shows that the ball is moving against the force of gravity. So t is equals to 5 by 10, which is 0.5 seconds. So that ball took 0.5 seconds to reach an initial speed of, to a final speed of 0. Now from there on it falls in the remaining time, which is 2 minus 0.5, which is nothing but 1.5 seconds. So in the remaining time of 1.5 seconds, the body falls through a height h before reaching the water surface. So the value of h when can be given by h is equal to ut plus half gt square. But however, u is 0, hence h is equals to half gt square. So h can be given as half into 10 into t is 1.5 square. So that is 1.25, pardon me, it's 11.25 meters. Also, the height which is traveled from this point to this point is given by h dash, which can be given half into 10 into 0.5 square, which is nothing but 1.25 meters. Therefore, the height of the bridge is 11.25 minus 1.25, which is nothing but 10 meters. Hence, option D is the correct answer. The average velocity of a body moving with uniform acceleration after traveling a distance of 306 meters is 34 meters per second. If the change in velocity of the body is 18 meters per second during the time its uniform acceleration is, the four options given are 1 meters per second square, 2 meters per second square, 3 meters per second square, and 4 meters per second square. Let u and v be the initial and final velocities of the body. So average velocity can be given as u plus v by 2, which has a value of 34. Therefore u plus v is 68. And the change in velocity, that is v minus u, is given as 18. So multiplying this to u plus v into v minus u is equals to 68 into 18. So that is v square minus u square is equals to 68 times 18. For uniformly accelerated motion, v square is equals to u square plus 2as. Therefore, a can be given as v square minus u square upon 2s, which is 68 into 18 from here divided by 2 times 306, which is nothing but 2 meters per second square. Hence, option D is the correct answer. Hence, option B is the correct answer. A body moves along a straight line with initial velocity u and uniform acceleration a. Sum of the distances travelled by the body in the tth and the t plus 1th second is 100 meters. What is the velocity after time t seconds? The four options given are 75 meters per second, 50 meters per second, 40 meters per second, and 25 meters per second. The distance travelled by an object in the tth second is given by the general formula u plus a by 2 times 2t minus 1. So, similarly for t plus 1th second, the distance would be u plus a by 2 times t plus 1 minus 1. It is given that the sum of these two distances is 100 meters. So u plus a by 2 times 2t minus 1 plus u plus a by 2 2t minus 1, plus 1 is equals to 100. Therefore 2u plus a by 2 times 4t is equals to 100. U plus 80 is equals to 50. Now we know the general relation as V is equals to U plus 80. So by similarity of these two equations, we can conclude that V is equals to 50 meters per second. Hence option D is the correct answer. A metro train starts from rest and in 5 seconds achieves a velocity of 108 km per hour. After that, it moves with a constant velocity and comes to rest after traveling 45 meters with uniform retardation. The total distance traveled is 390 meters. What is the total time of traveling? The four options given are 12 seconds, 15 seconds, 9 seconds and 17 seconds. In order to solve this sum, let us draw the graph of how exactly the train is moving. So in the first region, the train is accelerating, second has a uniform velocity, and third, the train is retarding. So let's just name it as A, B and C. So the given speed is 108 kilometers per hour, which is nothing but 30 meters per second. And since the initial speed starts from rest, initial speed is 0. So along OA it is accelerated. Therefore, since V is equals to U plus AT, 30 is equals to 0 plus A into 5 seconds, that is T. Therefore, the acceleration we get as 6 meters per second square. And the distance which is travelled in 5 seconds, that is from point O till this point, the distance which is travelled is equal to half of AT square, which is nothing but half times 6 into 5 square, which is 75 meters. So this is first part of the answer. So for A to B, it travels with an uniform velocity. So the distance that is travelled is nothing but V2 or V times T2. Let T2 be the distance or time taken to travel from A to B. Now for the curves B to C, from B to C it is retarding, and x3 is given as 45 meters. It is retarding for a distance of 45 meters. So using V square equals U square plus 2AS, we get 0 is equals to 30 minus 2 times A dash 45. Here A dash because we don't know exactly what is the rate of retardation. Therefore A dash get as 10 meters per second square. If we are using V is equals to U plus AT, we get T is equal to U by A, which is nothing but 30 by 10, which is 3 seconds. But x1 plus x2 plus x3, the distance OA, OP, AB and BC is given as 390 meters. Therefore x2 can be found out as 390 minus 75 minus 45, which is equals to 270 meters. Now the time taken to travel 270 meters T2 will be x2 upon V, which is nothing but 270 upon 30, which is 9 seconds. And therefore total time T1 plus T2 plus T3 is equals to 5 plus the 5 seconds, the 9 seconds and the 3 seconds. 5 plus 9 plus 3, which is 17 seconds. Hence option D is the correct answer. A particle located at x is equal to 0 at time t is equal to 0 starts moving along the positive x direction with a velocity v that varies as v is equal to a times root x, where a is a constant. The displacement x of the particle varies with time t as the four options given are t raised to half, t cube, t square and t. The velocity is given as v equals to a times root x. So the velocity can be written as a derivative of displacement. Therefore dx upon root x is equals to a dt. Now let's integrate both sides from 0 to x and from 0 to t. What we get is 2 root x is equals to at. Therefore squaring both sides we get 4x is equal to a square t square. Therefore x is equals to our a square t square by 4. Therefore x is proportional to t square. Hence option C is the correct answer. A particle starts from rest its acceleration a versus time t graph is as shown in the figure. What is the maximum speed of the particle? The four options are 110 meters per second, 55 meters per second, 220 meters per second and 530 meters per second. Now, acceleration is given as the derivative of velocity with respect to time. So a can be written as v by t. So v is equals to a into t. So from this relation, we know that the velocity is nothing but area under this triangle. So area under this triangle is given as half into base into height, which is equal to half into 11 into 10, which turns out to be 55 meters per second. Hence option B is the correct answer. A particle starts from rest. Its acceleration at time t is equal to 0 is 5 meters per second square, which varies with time as shown in the figure. What will be the maximum speed of the particle? The options given are 10 meters per second, 15 meters per second, 20 meters per second and 25 meters per second. When an acceleration time graph is given, the velocity is a into t, that is the area under this curve. Since a is equal to dv by dt, so v is equal to a times t. So area under this curve is nothing but half into base into height, that is half into 5 into 6 is equals to 15 meters per second. Hence option B is the correct answer. The velocity time graph of a body is shown in the figure. From this graph we conclude that at point C, let us look at the graph. At point C, the graph first decreases and then increases suddenly. So the velocity is continuously decreasing, reaches the value 0 at this point C and again starts increasing. This can be concluded as the force was being acted in one direction, hence velocity was decreasing. Then rapidly the velocity starts increasing again. So from a low value it again goes to a high value, which means that the force opposes the body of the motion. Hence option C is the correct answer. A taxi driver wants to go from Mumbai to Pune at an average speed of 60 km per hour, but due to the traffic jam he could cover one-third of the distance at 40 km per hour. How fast must he drive on the rest of the highway in order to reach Pune in time? The options given are 60 km per hour, 70 km per hour, 80 km per hour and 90 km per hour. Let S be the distance between Mumbai and Pune. So the desired time to reach Pune would be distance by velocity. Velocity given as 60 km per hour. So the desired time would be S by 60. But actually he travelled the distance of S by 3 at a speed of 40 meters per second. So the time for the first half of the journey, or one-third of the journey, is S by 3 time divided by 40, which is nothing but S by 120. This is the time for the one-third of the journey. Now for remaining two-thirds of the journey, the time taken would be T2 is equals to 2S by 3, and let the speed at which he has to travel be x. So it can be written as 2S upon 3x. But we know that T1 plus T2 is equals to T, that is S by 60. So therefore S by 120 plus 2S by 3x is equals to S by 60. So solving for this we get 2 by 3x is equals to 1 by 60 minus 1 by 20. 1 by 120. So which is equals to 1 by 120. Therefore the value of x is equals to 80 kilometers per hour. Hence option C is the correct answer. A ball is thrown upward. After it has left the hand, its acceleration when a body is released, as long as it is in contact with the hand provides an acceleration which may increase or decrease. But as soon as it leaves contact with the hand, the only force of acceleration that acts on the body is nothing but the gravitational force, or the acceleration due to gravity, which is constant for a given limited height over this Earth's surface. Hence, we can assume that the acceleration remains constant, and the option A is the correct answer. A ball thrown upward with a velocity of 100 meters per second, it will reach the ground after the value of g is given as 10 meters per second square. Now the formula for time of flight is given as 2u by g, which is equals to 2 into 100 by 10. So the answer comes out to be 20 seconds. Hence option B is the correct answer. A body is thrown vertically upwards from the ground. It reaches a maximum height of 20 meters in 5 seconds. After what time it will reach the ground from its maximum height position? The options given are 10 seconds, 5 seconds, 2.5 seconds and 25 seconds. When a ball or a body is thrown upwards, the time taken to reach its maximum position and again to come back to its original position on the ground is equal. Hence, over here the option would match the time taken to maximum position. Hence answer is option B, 5 seconds. A ball is thrown vertically upwards with a velocity of 40 meters per second. What is the velocity of the ball after 2 seconds? The acceleration due to gravity is given as 10 meters per second square. The options given are 28 meters per second, 20 meters per second, 15 meters per second and 25 meters per second. Using the kinematic equation V is equals to U plus AT, the acceleration here is nothing but G, and since it is opposing the motion, so V is equals to U minus GT, since it would cause a retardation when the ball is thrown vertically upwards. So V is equals to 40 minus 2 into 10, which is equals to 20 meters per second. Hence option B is the correct answer.